This video is to demonstrate how to conduct a one-way analysis by hand. Before we start, I have a question and you must recall and reflect your understanding based on the question. The question is, when we use one-way ANOVA or completely randomized design, CRD. Let's look at example 4. 15 students were randomly assigned to 3 groups to experiment the 3 different methods of teaching statistics. At the end of the semester, the same test was given to all 15 students. The following table gives the scores of the students in these 3 groups. Before we continue with the calculation, I would like to advise to you to write down all the information or variable involved in this study. The first one is a treatment. What is a treatment in a study? The treatment is the condition that we impose to the experimental unit. What we impose to our experimental unit, which is the student. We impose the teaching method, so the treatment is the teaching method. How many treatment do we have? We have one treatment, teaching method. And under teaching method, we have 3 level of factor types of teaching method. Method 1, method 2, and method 3. So we have 3 level and our factor is types of teaching method. Since we have only one treatment or independent variable, so we will use one-way ANOVA design. We back to the question. Question A, calculate the value of the test statistic F. Let X be the score of the student. The X is a data point. The data point in the study is the score of the student. What is K? K is a number of a different group. We have 3 groups, so we have 3K. And I is referring to the sample size of each of the group. TI is the sum of value of each of the group or the sum of score of each of the group. Capital N is the sample size of group 1 plus sample size of group 2 plus sample size of group 3. And summation X is the total score of group 1, total scores of group 2, and total scores of group 3. The total sum of square SST is the sum of treatment sum of square and error sum of square. So if we have treatment sum of square plus error sum of square, we will have total sum of square. To calculate the value of MSA, mean square treatment, and MSE, error mean square, we first need to compute the treatment sum of square SSA and error sum of square SSE. The formula of SSA, SSE, SST, MSA, and MSE are given below. SST. I'm sure you are familiar with the formula of SST. SST is given by summation of x square minus summation of x, and then we take in square, divided by capital N. Treatment sum of square SSA is given by total of scores of group 1 square divided by sample size of group 1 plus total of scores of group 2 square divided by sample size of group 2 and total of scores of group 3 square divided by sample size of group 3. And we have last term, summation of x, and then square divided by capital N. The last term of SSA is equal to the last term of SST. And simply we have SSE or error sum of square equal to total sum of square minus treatment sum of square. Mean square treatment or MSA is given by treatment sum of square divided by K minus 1, and error mean square MSE is given by SSE divided by N minus K. To obtain the F calculated, we will start with calculate the value of sum of square. I always start with calculating the SST. Recall back the formula for SST. You should be able to read the formula and substitute the correct information. I'm sure you know how to get this value by using a scientific calculator. Summation x squared is given by 8709 minus summation x is 1081 square divided by sample size. The total sample size is 15 and total sum of square is given by 2804.9333. Now we calculate the SSA. This is the formula for SSA. Let us recall this notation. Let us take a look at the first term. T1 is the total score of group 1, T2 is the total score of group 2, and T3 is the total score of group 3. We prepare for you the table of the total of each of the group. Total score of group 1, 3 to 4. How do we get this value? 48 plus 73 plus 51 plus 65 and plus 78. We add all the score of group 1, we will get the total score of group 1. And the sample size of group 1, we have 1, 2, 3, 4, 5. So we have 5 here. Total score of group 2, we add all the score here, 55, 85, 70, 69, and 90. We have 369. And the sample size of group 2 is 5. And last one, 84 plus 68 plus 95 plus 74 plus 67. The score of group 3, we add, we will get the value of 388. And the sample size is 5. So T1 is 3 to 4, T2 is 369, and T3 is 388. We replace the value into the formula. We have 3 to 4 square divided by 5, 369 square divided by 5, and 388 square divided by 5. So this is the first term minus the second term. The second term of SSA is the same as the second term of SST. So I just replace in our calculation for SSA. 1081, we taking square, and only we divide by the total of sample size. So sum square treatment is given by 432.1333. For convenience, all the calculation just now we record in ANOVA table. So this is the ANOVA table. In ANOVA table, we have two sources of variation. The first one is the variation between group. This variation is due to different method or different treatment. And another one, we have the variation from the other factor or error. Second column, we have the degree of freedom for the treatment, K minus 1, and degree of freedom of the error, capital N minus K. The third column, we have column of sum of square treatment, and sum of square error. Treatment mean square is given by treatment sum of square divided by degree of freedom of a treatment, or simply you divide these two value, SSA divide K minus 1. Same goes to error mean square, SSE divide by N minus K. Finally, we have the column of F calculate. F calculate is MSA divide by MSE. We substitute the value that we have just now. For the treatment, degree of freedom, we have K minus 1. Since we have 3 number of group, so minus 1, we have 2. Degree of freedom of error, and minus k. The sample size, the total sample size is 15 minus 3, then we have 12. And total n minus 1. 15 minus 1 is 14. Now we focus on column sum of square. 432.1333 is the value that we calculate before for SSA. 2804.9333 is the value of SST. If you subtract these two values, SST minus SSA, then you will have SSE. Mean square treatment is simply 432.1333 divided by 2, and mean square error 197.333 is simply 2372.8 divided by 12. And F calculated, you divide these two values, and you have 1.0927. Question B. Test at 5% significant level the claim that there is no difference among the population mean scores. So here we have to conduct the hypothesis testing. The goal here is to compare the population mean. So I've breaking this down into 5 steps. Steps number 1 is to state the hypothesis. Remember that we always have the same null hypothesis, which is the population mean are equal, and the same null hypothesis, which mean the population mean are not equal. We have 3 methods, method 1, method 2, and method 3. Therefore, we have population mean 1 equal to population mean 2 equal to population mean 3. And alternative hypothesis, at least one population mean is different. Or you can write into word the null hypothesis, there is no difference among the population means, and alternative hypothesis, there is a difference among the population means. Step number 2 is the critical value. Our critical value is given by F, alpha, degree of freedom 1, and degree of freedom 2. Degree of freedom 1 here is referred to the degree of freedom of our numerator at the top, and degree of freedom 2 is referred to degree of freedom at the bottom or denominator. Since your alpha is 0.05, therefore you have the critical value f 0.05. The degree of freedom of numerator and denominator we have to refer to our ANOVA table. Degree of freedom of numerator is 2 and degree of freedom of denominator is 12. If you look at the F table, then you have the value of 3.89.
If we explain this into F distribution figure, then we have this kind of figure. We have the value of 0 here, and we have the alpha at the right here, 1 minus alpha here.
Remember that one-way ANOVA test is always right tail with rejection region in the right. And this is non-rejection region. The value that separate between rejection region and non-rejection region is our critical value. So the critical value is here 3.89. So any F calculated that fall in this region, then we have to reject H0. So we can write our decision rule. We reject H0 if F calculated is greater than 3.89. Step number 3 is to make a comparison. We have to compare our F calculated that we obtain in ANOVA table with the critical value. Based on our ANOVA table, we have F calculated 1.0927. 1.0927 is less than our critical value 3.89, which is it falls in this region. Therefore, we fail to reject H0 or we do not reject H0. So do not reject H0 should be our step number 4, the decision. And last one, step number 5 is the conclusion. Since we do not reject H0, then we can say that there is insufficient evidence at 5% significant level to conclude the alternative hypothesis, which is there is a difference among the population means. Or in other words, we can say that there is no difference among the population mean in this case.